I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine a future where the oils that fuel our cars, power our planes, and make up the cosmetics on your shelf aren't extracted from the earth or tropical plantations, but are brewed in labs using microbes and plants. As the world races to decarbonize, biotechnology is stepping up, revolutionizing oil production without harming the environment or draining precious resources. Traditional oil production faces a massive challenge. By 2027, global oil consumption is expected to hit 104 million barrels per day. That's not just a number. It means rising greenhouse gas emissions, devastating oil spills, and ecosystems pushed to the brink. But what if there were a way to meet this demand sustainably? Enter microbial factories. Special microbes like oleaginous yeasts and algae can store up to 80% of their biomass as oils. Scientists use synthetic biology tools to supercharge these tiny oil producers. Thanks to CRISPR gene editing, they reprogram microbes like Yersinia lipolytica to efficiently turn sugar, methane, or even captured CO2 into triacylglycerols, the same building blocks in palm or coconut oil. What makes this even more remarkable is waste carbon valorization. Instead of using expensive food crops, engineered microbes can feast on industrial waste, steel mill off-gases, biogas, or even plastic waste. Picture microbes that take pollution and turn it into valuable oil. Companies like LanzaTech are turning industrial emissions into jet fuel, while Semvita Factory produces carbon-negative energy by reactivating depleted oil wells. Studies now show microbial oils can cut emissions by up to 78% compared to crude oil. Algae farms are becoming solar-powered oil refineries of the future. Breakthroughs include algae strains engineered to hold 40% oil content, double the usual yield. Some strains now thrive in salty or brackish water thanks to CRISPR tweaks, meaning they don't compete with farmland. Imagine huge algae farms on non-arable land supplying up to 10% of global oil by 2035. Even more game-changing are carbon-negative platforms. For example, Global Algae Innovations operates algae that absorb 2 tons of CO2 for every ton of oil they produce. Living carbon enhances plants to not only capture carbon, but generate bio-oil fit for industry. These processes could earn carbon credits valued up to $50 per ton. Engineered oilseed crops are also making waves. Camelina sativa, a robust oilseed plant, grows on marginal lands with minimal inputs. Genetic modifications double its oil yield and tailor fatty acid profiles, for example, high oleic oil for jet biofuels or omega-3 for aquaculture. To prevent gene escape into the wild, researchers designed biosafety features like self-destructing seed pods and inducible sterility systems. One of the most exciting innovations is leaf oil technology. Scientists combined clever gene modifications to enable plants like tobacco and sorghum to secrete oil from their leaves, up to 20% of dry mass. Since leaves regenerate faster than seeds, this method could produce more oil per hectare than palm plantations, without harming rainforests. Then there's precision fermentation, brewing designer oils in giant labs. Amyris, for example, engineers yeast to produce squalane, a key cosmetic ingredient once sourced from shark livers. Checkerspot uses algae-derived oils to manufacture eco-friendly outdoor gear. These lab-grown oils eliminate deforestation, pesticide use, and ethical issues tied to animal products. What about molecular design? Advanced microbial platforms now let scientists fine-tune oil molecules, adjusting chain length, branching, or saturation. This enables creation of high-performance lubricants and dairy-free butter mimetics without livestock, methane, or land exploitation. Of course, challenges remain. Microbial oil costs around $3,000 per ton, much higher than fossil crude's $600. But hope is rising. Deinove cut costs by 60% by using extremophile bacteria that ferment cheap biomass like agricultural waste. Governments help too. The U.S. Inflation Reduction Act now covers up to 30% of R&D costs in bio-oil production. Breakthroughs keep coming. Hollow fiber membrane bioreactors now deliver microbubble oxygen directly to microbes, solving the problem of high oxygen demand and fermentation. Think of it as giving microbes precisely what they need without waste. Another breakthrough is the milking of algae. Salt shocks trigger algae to release oil continuously, avoiding expensive crushing. Plus, AI-driven metabolic models now monitor microbes in real time, dynamically adjusting enzyme levels to handle feedstock variability. It's like having a digital brain, keeping the process optimized and efficient. Sustainability isn't just a buzzword, it's measurable. Life cycle assessments reveal microbial oils grown on waste gases emit up to 90% fewer greenhouse gases than palm oil, use 90% less water, and require almost no land. Bioreactors are stackable, using vertical space to further reduce the footprint. Policy shifts accelerate progress. The EU's RED III framework limits palm oil imports, pushing subsidies towards biotech alternatives. In the U.S., clean fuel credits encourage carbon-negative fermentation. Commercial momentum is surging. The U.S. Sustainable Aviation Fuel Grand Challenge aims for 3 billion gallons annually by 2030. Cemvita Factory recently achieved commercial-scale production of 500 barrels of oil per day, 5 years ahead of schedule, producing oils that mirror palm oil but without the environmental harm. The future of oil is no longer drilled or harvested, it's brewed, milking the power of microbes, plants, and advanced technology to meet our needs while protecting the planet. The biotech oil revolution isn't just coming, it's here. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.